Welcome everyone. In this video lecture, we will solve a GATE 2019 question in which we have to identify the functionality of the circuit using this circuit which consists of two PMOS and two NMOS. So this one is a simple question. So by seeing this circuit, we have to find the which functionality it will give, like latch, XNOR, SRAM cell, or XOR gate. Okay. So before that, this one is the circuit, so I am again redrawing the circuit because this PMOS is also connected to B and AMOS, this A is connected to this in. To I am just simplifying this circuit by again redrawing the same circuit. Okay, so this is the same circuit. So what basically we have to do, we have to make a truth table. Okay, so how we have to make the truth table? Before that, I'm just, because this in is connected to B input, so I'm just writing this is B and this is a the same thing is there. This one is our B, okay, and this one is our A. So A and B, the same thing we are writing. Now what we can say, we have to write like this, means two inputs are there, so we are writing A and B as a input and F is the output. Okay, so there are four possibility for the inputs. It may be either 0 0, 0 1, 1 0, and 1 1. Now this, for this four possibility, we have to find the functionality of the circuit. Okay, so for the simplification, what I am writing, I am saying this one is our M1 transistor, M2 transistor, say M3 transistor, and M4 transistor. Why I am writing? Because we have to identify this M1 and M2 is our what, PMOS. Okay, I'm selecting some different color, and then M1, M2, and say M3 and M4 is our NMOS. We have to identify which one is on and off kind of thing to solve this question. Okay, so when we are saying A and B are 0, A and B are this, both PMOS will be on when both are 0. Now for the on term, I am writing O on, and for off, I am writing off, small f off. Okay, so now in this case, both will be on for the low value of 0 value. So I am just writing on, and on the other hand, M3, M4, we are giving 0. So this one is basically our NMOS and this one is PMOS, so we can add arrow also for. Okay, so now in this case, both will be in the off condition. So this one, this will be no role of these two transistor, and all the output voltage come across to this one because this will be on. So this VDD will become, so we can say this value will be 1, or we can simply say the almost VDD high value for the 0 input. Okay, similarly in the next case, what we have to do, we have to do for 0 1. So when 0 is M2, so M2 is 0, so M2 will be on, M2 will be on, and okay, and M1 is connected to B, M1 is connected to B, so this is, we are giving 1 as a input, so it is off. Okay, now M3 is connected to, gate is connected to B, and B is what, 1. So M3 will be on and another will be off because M4 is connected to 0, so it will be off. Okay, so now here M2 and M3 is on, M2 and M3 is on, but this will be cut out because in this case our M1 is off. So M3 and M3 is on. So this one will be on. Okay. M3 is on. So channel will be formed. So what should be the A output? A input will go from this side. A input. Okay. So this case A will be 0. So this one is 0. Similarly, okay, for more better visualization, what I am doing, this one is a yellow one. So this yellow one is go like this. Okay. And this one for output, this one, first one. Okay. Now next, when A is 1, B is 0. A is 1, B is 0. So A is 1. A is 1 means M2 will be off. So make it off. A is 1 means M2 will be off. M2 will be off. Simple concept. And M1. M1 we are giving B input. B is 0. So it should be on. Just because of this. And now in this case M3. M3 is connected to B. And B is what? 0. So it should be off. Okay. And when M4 transistor. M4 is connected to A. So A is 1. So it should be on. Just reverse of this. It will be very simple concept is that n. Okay. Now in this case the M1 is on. M1 is on. That is our this one is on, but M2 is off. Okay. And M3 and M4 in that one, M4 is on. So this one will be on. So I'm selecting green color. This one will be on. So at that time B output will be 0. So that B will be go from this side. Okay. So F will be 0. Okay. So again I am highlighting this one. So this way B is 0, then this will be our functionality. Okay. Now when both are 1 1 1. Okay. So when both are 1 1, what we can say, simply say, when both are 1 1, A and B are, so A and B are off, and both NMOS will be on. So this one is off, so it will cut out. Okay. And 1, so 1 is in the both side 1, so it is short circuited, so it should be will give the 1 value. Okay. So the functionality will be F will be A dash B dash plus AB, because we have to take this. Okay. And this is nothing but simply A plus B. So this one is our X nor. So this one is the X nor output. So this is all about this simple question, but we have to know the basics. Okay. With when gate of gate of okay, for the brief I am just writing one line is that to when gate is 1, then NMOS will be on, and when gate of is 0 across the PMOS, so it should be on. And if gate is 0, then NMOS will be off, and gate is 1, so PMOS will be off. Simple concept is there. So in that way we can identify this question very simply by giving, by writing. If this type of question will come, you try to make a truth table. Okay. Then after making this truth table, you can easily solve this question. So this is all about this question. So thank you for watching this video.